Okay, so everybody should be on this page right now. Andrew, where's your packet? Go ahead and pull that out. You can finish that up later. So, for today, we're looking at fraction multiples because these go with the equivalent fractions. Remember? So we're going to do this worksheet, and then we're going to do an equivalent fraction maze. Okay? So this one, I think this one's pretty self-explanatory, but remember, read the instructions. It says, find the multiples of the fractions below. So we're going to keep going, all right? So I think what we'll do is we'll do the first one together here, and I'll explain the maze as well. Then we'll give you guys some time to work, make my way around, see what you guys are doing, and then we'll come back together and we'll do everything together at the end, okay? But even if I read you the instructions, I want you guys to please read them on your own as well. So, the maze though, this one, you're going to complete the maze by coloring all the fractions that are equivalent to 1/2. 1/2. These are the easiest ones, right? You guys are good with 1/2. And I think that's all we actually have here today. Yeah, and you'll be excited to do your writing. So this is easy. We're just doing a little bit of review on math today, and that's it. And if we have time, then we'll do some fractions Kahoot. Okay? All right, so let's do this one really quickly together, and then we'll break and have you guys work. Jed, do you have a question?
I noticed that the numerator goes upside down and the denominator goes upside two.
Good. And that's exactly right because, look guys. That's right, because these are equivalent fractions to 1/2. Equivalent fractions to 1/2. So when they say fraction multiples, what we mean is we're looking at that bottom number, right? So this is a pattern that we've seen before. Okay, so everybody together. What is the next fraction then?
4/8.
What's the one after that?
5.
And what's the last one?
12.
Now, what is the relationship between 6 and 12? What is it, Tava? That's right, which means that 6 is Schmidt?
6 is half of 12.
That is right. What about 5 and 10? Ariana? That's right, 5 is half of 10. Brewer, what about 4 and 8?
4 is half of 8.
That's right. What about 3 and 6? Jed?
3 is half of 6.
That's right. What about 2 and 4? Andrew?
3 is half of 2.
And then what about 1 and 2? Briggs? Go ahead and sharpen. What about 1 and 2, guys? Andrew? That's right. 1 is half of 2. Halves are the easiest ones. So when you guys get down to this right here, you are looking for equivalent fractions that are, or fractions that are equivalent to 1/2. So you're going to be coloring in any of the fractions that are equivalent to 1/2. So remember, you're looking for the numerator, the top number, to be half of the denominator, the bottom number. And that's going to tell you if it's an equivalent fraction to 1/2. So obviously the first one that you would color in is going to be 1/2, right? And then you're going to keep going. Okay? Until you get to the end of the maze. So, I think these are going to be pretty easy for you. I'm going to make my way around the room and then we'll come back together and we'll review everything. So, let's go ahead and do this for, I don't really think it's going to take that long. Let's go for about, let's do this for about maybe 10, 15 minutes. We'll go until either 8:45 or 8:50, depending on where you guys are. Okay? Aiden, stop messing with your hand. You need another Band-Aid? Okay. Andrew. Good. I told you I don't think this is going to take you guys very long at all. Okay, so let's go ahead and get started. And then we'll come back together. We will review everything. Okay? And I want us to come back to this page first, okay? We're going to look at it together. Let's make sure we're all on the same page, literally and figuratively. Okay. So, what's your question?
On this one, equivalent fraction made one. I colored in it.
There are other ones, but there's not just one extra half. You want to throw that out? Well, let's start on this first. Okay. Let's see. So we already got the first one. We established that there are two patterns, right? Actually, more than two patterns, right? There's the pattern on the top, where our numerators are going up by 1. There's a pattern on the bottom, where we're skip counting by 2s, right? And because they're halves, it means that every one of the numerators is half of the denominator, right? Thumbs up? You guys get that? Halves are not bad, right? Halves are pretty easy. I think they're probably the easiest ones. Now, let's take a look at the next ones. Now, looks to me like the numerator is doing the same thing, correct? Are we going up by 1? 1 every time? So, then we can probably do, I don't want that color. That's too hard to see. Do that. So we can probably do this, right? But what are we doing with what are the denominators doing? What are those going up by? Madeline?
They're going up by 3.
They're going up by 3s, right?
And I know how to skip count by 3.
Good, good. So everybody, what's this one?
4. No.
What's this one?
515.
What's this one?
618.
Good, good. And remember, the other pattern here, go ahead, Ariana. The other pattern here is that if you were to take 18 and divide it by 6, you would end up with 3, right? If you were to take 15 divided by 5, you'd end up with 3. Same with 12 divided by 4, 9 divided by 3, 6 divided by 2, right? All of those will give you a quotient of 3. And these are all multiples of 3. That's why these are called fraction multiples, because we're working with multiples. We're looking at skip counting with our denominators, right? Now, what about this one, though? What about the next one here? We're on 1/4. We're on quarters, right? 1/4. Now we're looking for equivalent fractions to 1/4. We got 2 eighths. What are we doing? What's that pattern on? What's our pattern with the numerator, Brewer? Looks like we're going up by 1 again, right? You guys think that's right? We sure? Should we double check it? You guys are positive?
Yeah.
Now, what about the denominator? What are we doing with the denominator, Andrew? Skip counting by 4s, right? So what's the next one then?
12.
What's this one?
16.
What's this one?
5.
And what's this one? Good, and now we're looking at the same thing, right? If you were to divide 24 by 6, what would we get? What's 24 divided by 6, Jack? That's right. What's 20 divided by 5, Schmidt? What is 16 divided by 4, Tava? What is 12 divided by 3, Madeline? What is 8 divided by 2, Talon?
4.
What is 4 divided by 1, Sellers?
4.
That's right. That's right. Okay, so what about this one, though? Things are getting a little more complicated, aren't they? What's happening with our numerator? What's happening here, Madeline? So we're skip counting by 3 for the numerator now, right? 3, 6, what's next?
9.
What's next?
12.
What's next? What's next? Now what's happening with our denominator? Jed? Okay, so what's the next one then?
9, 15, 20, 30.
Okay. So we're not in unison. Remember that word unison? But you guys have it. But what happens here? We can't do the same thing, can we? Because you can't divide 30 by 18. Well, you can, but you're not going to get an even. You're not going to get an equal number, right? It won't be equal. You'd end up with some remainder, but we're not even that far in division, right? So what exactly is happening here? How do we know How do you know that 18/30 is equivalent to 3/5? How do you know that? Ian? How do you know?
Lots of ways you could find out.
How do you find out?
You could say, draw like a circle or a square and put it up into like those numbers.
That's true. We could make a model, right? We could draw it out. I could take 2 pizzas and I could cut them into 30 slices and 18 slices. And those better be big pizzas, because otherwise you're not getting a very good deal if you're getting that. 18, so yeah, exactly. It'd be like about this thin. Who wants a piece of pizza that's like this big? I don't. I want a piece of pizza that's like this big. You know, like one of those gigantic slices. So, but let's talk about this. So 18/30. How are we going to get it to 3/5? What can we do to get that number down, simplified to 3/5? That's its simplest form. How do we do it, Wilkins?
31.
Yes. How do we do it, Franks? 2 things. Can't divide the numbers. Can't divide the numbers. Can't divide them by each other, but we can divide them by something else. What can we divide them by, Jack? Yes. You're getting a water, Jack? Yes. Yes. Ariana, what can we do? You're right. So what if we did divide them by 6? You're right, but what would 6 be called? What do we call it? What do we call it? Tell it?
Water.
Okay, go ahead. Madeline, what do we call it? These are equivalent fractions, but yes. Guys, get your water. What do we call it though, brother? Yes. Come on, nobody remembers what we call this. They are equivalent fractions, but how do we know they're equivalent? Now, Ariana, she already said it. She told us what we're going to do. She told us what we're going to do, but there is something that we call this. She told us what we're going to do. She found a number. She found a number that you can divide both of these, the numerator and the denominator, by to reduce it or to simplify it to 3/5. She found a number that works for both of them. What do we call that? What do we call it, guys? You guys don't remember? She knows how to do it. Go ahead. But you guys don't remember what it's called? A common factor. A common factor, because if you take 3 multiplied by 6, you get 18. If you take 5 multiplied by 6, you get 30, right? So when Ariana said we can take a 6, remember, whatever you do to your numerator, you have to do to your denominator as well. But we found our greatest common factor. This is the biggest number that can go into both your numerator and your denominator to simplify it all the way down to 3/5. That make sense? That's how we know with every single one of these. Every single one of these works that way. But it's not 6 for every one of them, is it? The common factor is not 6 for every one, is it, Andrew? Yes. Jen. What's the common factor that we can do to get 15/25 all the way to 3/5? Ariana? It's 5. Because what happens when we divide 15 by 5? What's 15 divided by 5, guys?
3.
What is 25 divided by 5, guys?
5.
Yes. So this would bring it back to 3/5. Now what about 12/20 though? What's the common factor there? Jen?
Divided by 4.
That's right. Divided by 4. See, look at the pattern, guys. I'm going to ask everybody, what can we divide 9 and 15 by to get to 3/5? Everybody.
3.
That's right. And what about this one?
2.
Good. And then obviously 3/5 divided by what is still going to be 3/5, right? See, so it's a slightly different pattern, and that's because we have, remember how fractions work. The other ones were a little bit easier, and we saw our numerators going up. Oops, wrong direction. We saw our numerators going up by 1 every time, but that was because our numerator was 1 here. But because our numerator down here is 3, it has to go up by 3, and we have to do something different to get down to our most simplified form, right? Or to continue moving up. We did the same thing. Think about it in reverse, right? You know that 5 times 2 is 10, right? 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. It's the same thing. Remember the relationship between multiplication and division. Go ahead, Amy. Abigail, question? Yes, please do. Okay, guys, what's happening with our numerator here? What is it? What's happening there, Ariana? We're going up by 4, so what's the next one? What's our next one, guys? What's next?
16, 20.
Everybody, what's next?
24.
Okay, what's happening, though, with our denominator? It's bigger, isn't it, Jack? Going up by 6, so what's the next one then?
18,
24,
36.
Good. So, and this is why I said I had a couple of you guys ask me, well, why would I use my multiplication table for this? Well, this is why, because we're talking about multiples. This is why. The top one, these are multiples of 4. The bottom one, these are multiples of 6, right? So you skip counted by 4 on the top, you skip counted by 6 on the bottom. How do we know that 24/36 can be simplified to 4/6? How do you know? What do we do? What's the thing that we find?
Common factor.
And we want it to be the greatest one, right? The biggest one that we can find? Well, so what is the biggest one then? How can I get 24 down to 4? Mariana? I have to do the same thing to the bottom one, don't I, Andrew? What's 36 divided by 6? Remember? That's right. That's right. That means that this is going to give us 4/6, right? We just reduced it. But we're looking at the same pattern here. We can't take 20 divided by 6, and you can't divide 30 by 20. But what would this be then? How can I get 20 down? 20 divided by what is 4? Schmidt. What times 4 equals 20? Yeah, what times 4 equals 4 times 4 equals 20?
4 times 4.
Yes. So if I divide that by 5, then I have to divide this by 5. And then that will bring us all the way back down to here. The 4/6, right? Make sense, guys? So then what do I divide these two by? What's our factor here? Common factor here. Please stop doing that. What's our common factor here? Guys, remember, same thing. 6, 5. What's next? What's next? 4. What's next?
3.
Hey, guys, at the same time, what's next? Right? Do you see the pattern? It's the same type of pattern we had up there. And it makes sense, right? This is how you can always check. Look for the common factor. 8 divided by 2 equals? What's 8 divided by 2? No, 8 divided by 2, guys. 12 divided by 2. 12 divided by 2. Guys. 6. It's the same thing if I was asking what's 6 times 2 and what's 4 times 2. Okay, last one. This is definitely a good one to have used that multiplication chart for. What are we doing on the top? What are we doing on the top, Andrew? By 5s, right? So what's next?
10, 15, 20, 25, 30.
Okay, what about this bottom one?
16, 20.
Wait. What are we counting by? What are we counting by here? Wilkins. 8. That's right. Madeline, are you using a giant pen or are you playing with it? If you're using it, use it. If you're not, then put it away. Okay. Thank you. What's next?
16.
What's next?
42. 40. 48.
That's not right.
40. 48.
Okay. What about this one?
48.
Now, look at the pattern. Look at the pattern from above. How do I know that 30/48 can be simplified all the way back down to 5/8? How do I know? How do I know, Schmidt?
You divide it by 6.
So if I take 30 divided by 6, will I get 5? Will I get 5?
Yeah.
If I take 48 divided by 6, will I get 8?
Yes.
Does everybody agree with that? So then what's our next common factor? What is it, guys? Yes, Brewer. What's the next one?
4.
What's the next one?
2. 1.
So 10 divided by 2 is what? 10 divided by 2 is what? 16 divided by 2 is what? Okay. So then wait, what times 5 is 10? What times 8 is 16? Okay. What times 8 is 48? You sure?
6.
6. Okay. Does that make some sense? You see some patterns? I know it gets a lot harder once we get up into the higher fractions where we have more parts out of our fractions, right? It does get a little bit more challenging. But does it make some sense? Thumbs up? Thumbs up if you're getting it. Thumbs up if you're getting it. Sellers, you getting it? Aiden, what do you think? Sideways thumbs if you're kind of getting it. Down thumb if you're not getting it at all. And then sideways thumb and up thumb if you're getting it or you think you're getting it. 2 thumbs up if you think it's awesome. A thumb down and a thumb up if you can do it but you don't like it. That's Ian. He says he gets it but he doesn't like it.
Yeah, it gets harder.
It does get harder. But that's okay. It makes sense then once you remember the patterns, right? Teva.
I kind of get it, but I like it.
You like good. And you'll like it more once you get it all the way. Andrew.
I like it. So I get it. I don't like it.
You get it, but you don't like it that much. Okay, fair enough. Fair enough. All right, let's look at this equivalent fraction maze, guys. So I saw a lot of you guys rush through it and got all the way down to the end. Madeline, you have a question?
What does this qualify as?
That is somebody who can bend their arm in a really weird way. Okay. So we had 1/2 and 5/10. Those are easy ones, right? What's next? What else? Is there anything else on this top line that would count? Let's go line by line. Anything else on this top line that is equivalent to 1/2? Brewer? Which one?
1/8.
Is 1/2 of 8? What'd you say?
4/8.
4 is half of 8. Yep. That works. Okay, next line. What's on the next line then? Jack.
2, 4.
That's one of them. Is there anything else on that line? Is there anything else on that row right there that works? Andrew?
1. Yeah, and 2. 2.
Can you draw?
Yeah, scribble.
Not on the board. You can scribble on your own. I see you missed some.
4, 15.
So, okay, is there anything on this row? Anything else on this row?
Yeah.
Anything else on this row that's equivalent to 1/2? Okay, what's equivalent on this row to 1/2?
7, 14.
What else?
3, 6.
Okay, what else?
5, 10.
Anything else?
No.
Okay, what about this next row then?
12.
Right? 6 is half of 12. What else? Anything else?
No.
Okay. What about this one?
4 8. 7 14. 1 half. 4 8.
There is no 4 eighths on this one other than the one that I crossed out.
The bottom. Go down.
Yeah, we're not on the next row yet. Okay, next row.
4 8.
Is that the only one?
Yeah.
Okay, last row.
6.
Is that it?
Yeah.
Are we missing any?
No.
Do you guys see that every single one of the numerators is half of the denominator?
Yeah.
That's why they're equivalent to 1/2. Because if I drew out a pizza that had 8 slices, and I said to you, I'm going to give you 4 of them, I will have given you half the pizza, right? Make sense? So, some of you just went all the way down, but there actually were a couple other ones on the side, right? Yeah. Now remember, I saw a few of you guys choosing other ones. You're looking for, when you're doing 1/2, you're just looking for the numerator to be half of the denominator. The top number should be half of the bottom number, okay? Halves are probably the easiest ones to find. Jack? You want to do more of these?
Yeah.
Okay. Save a question. Oh, you like these? Okay. Good.